now. Oh, look, there's that, but I can see it fine now. It wasn't there last time. It was like hidden up here or something.
Because you were sharing your screen.
Oh, that's right. I was sharing my screen. Yeah. I'm not sharing it right now. Oh, I need to share my screen. Uh-oh. Yikes. Otherwise, that would have been kind of mysterious for Doug and the recording. Okay, let me do that real quick. Share screen. All right. Share sound. Okay, share. Right. Yeah, there it is. Now here's, oh, I see. Look how tiny they made that. Good grief. They're just like after me. Okay, so I think I'm sharing sound. Life should be good. Yeah, Doug, tell me if you don't hear anything when I, well, do you want to check it real quick?
Yeah.
Okay. Let me see here. You hear that?
Yeah, I think so. I mean, yeah, it's good, pretty good. So.
It's frogs. Yeah, okay. All right, we're going to use them today. All right. Okay, so this will be, like I said, the last of the RTC Mix Hardcore classes. And I'm going to do the first half. And I basically just want to finish off some things that I want you to know about RTC Mix. So it's going to be kind of random. It won't follow a real trajectory. We don't have a particular topic like L systems or fractals or anything like that. And then Doug's going to take you the second half and show you some of the more advanced features, you know, if you're interested in kind of exploring, because this is a very rich language. You know, I'm just showing you the very basic stuff, you know, because that's what you're going to need. All right. So first thing I want to show you is kind of how to use signal processing in RTC Mix, okay? And what I'm going to do is I'm going to bring up, I have some apps pre-built. I'm going to bring up this Verb Ambient one. Some I'm going to like write code for, some I'm not, okay? This one I'm not because it's pretty much got a lot of stuff there. I want to go over something that I kind of hit last time, and that's this idea of having more than one of these scripts on an RTC Mix object. Okay, especially when you use one for initialization and then one as it's going, all right? And you call the particular scripts. If I just hit the bang button, it will just go to the currently active script, okay? And we're not even going to go into that. But I'm going to open the script 0, and this is basically all the stuff that I don't need to run every single time I'm trying to synthesize something, okay? So basically, this is, you know, it sets up that pitch array. This is that ambient app that I did, I think the second class, okay? There's the duration, the amplitude. I made a wavetable that goes basically up and then down, so it's a fade in and fade out. And then I made the waveform be a triangle wave. I don't have to make that waveform every single time that I call the main stuff. What's the main stuff? Well, that's this OpenScript 1. Now that I've all done that elsewhere, all I have to do is choose my index, use that to choose my pitch, generate my wavetables, and then generate a max bang. And basically, I changed it here, rather than just saying, you know, make a max bang 5 seconds from now every time. I said, make a max bang that's the duration times something between 0.3 and 0.7. Well, what's the duration? Well, I set that in this. The duration is 15 seconds. Okay, so we're going to get like clusters of notes and things like that. And let's listen to it. Let me make sure I have my audio status set properly. No, I don't. Look at that. Zoom audio device. Okay, and we're going to keep the microphone there. Okay, so I turn this on, and then I have to initialize it by saying go script 0. That'll then run that script. Okay, and now go script run 1 should make the sound. There we go. Except, are you hearing it, Doug?
Yes.
You are?
Yes.
Okay, good. All right. Okay, so again, that's that nice little, now every time I start this again, I have to reinitialize it, okay? Because if I didn't, it would tell me it doesn't know a bunch of stuff. Like, it can't find Len pitches or anything like that because those are set in this. Once I hit that, then it'll start. Life will be good, okay? All right. So what I want to do, the next thing I want to do is I want to add, I mean, that sounds nice as it is, but I really like things that have a lot of reverb on them. So I'm going to add a lot of reverb. How am I going to do that? Well, I'm going to show you two different ways to do it, okay? First of all, let me get rid of these guys here, because in between there and there, I'm going to put another RT-CMix object here, RT-CMix tilde, and it's going to be a stereo object. I'm going to take the outputs of this and run it into the inputs of that one. Oh, isn't that clever? Okay. And what am I going to put in this one? Well, in this one, I'm going to put in one of my favorite reverbs. Let me get it up on the thing here. Go to rtcmix.org, go to the reference, go to the instruments. We're going to go down here to delays. It's called G-verb. It's a good sounding reverberator with long reverb times. Yeah, I like G-verb. So let's get this. And let me copy it out and put it in here as a comment so I can see what all the parameters are. And then let me fill in those parameters. Okay. Okay, so G-verb, the out skip, in this case, it's going to start right when we're starting all the notes. So the out skip is 0. The input skip, that's if you're using a file. We're reading the stuff directly. So the input skip is 0 because you can't go into the future. That's the way life is, I'm afraid. Duration, we're just going to want this to run the entire time. Once I start the reverberator, I'm going to be sending sounds into it. So I'm just going to say 9999. You know, I don't think class is going to last that long. Okay, amp. Now this is again, I explained this last time. If you have a signal processing thing, the amplitude is a multiplier, not a direct signal. Like we said 20,000 for wavetable because we were building the sound directly there. We said 20,000 for FM. This will say just 1, okay? Because we're going to multiply the incoming signal, all right? Then the room size, this is where you would look at say your documentation to figure out what all these things mean. But you know what? I'm not going to do that. I'm just going to go ahead and bring up, I think I've coded enough on this. Pretend like I'm still typing, okay? And what I'm going to do is bring up this one where I've finished all my typing, and that's what it looks like. Okay, so my amp I've set to 0.5. That was because I was getting distortion. The room size is 250. That's like a 250-foot room, so it's big. The reverb time, this is where I like the really long reverbs. The reverb time is 50 seconds. Yeah. Okay, and then these things, the damping and the others, you can read about them in the documentation, and this is like how loud the original sound is and all this nonsense. But the other thing I've added here is RT input audio. And that means that it's going to be looking for its input from those inputs on the top of the RT-CMix thing, all right? So let's do it. Now, the final thing you're going to see here is that I've also added an initialization bang that comes down to here because I have to start that script up as well as start the initialization script here. Okay, so once this happens, that guy starts, it's waiting for sound to come in. When I hit this, I'll send sound in, and you'll hear nicely reverbed stuff.
I don't know what just happened.
It's weird because it happened exactly when I hit go on this. Okay, all right. So now, you may not be able to tell, but that's actually pretty reverbed, and I'll show you how you can check it, okay? You can't, I mean, it's filling it out. It's the reverb is more an effect there than actually like a reverb that you're hearing. Because if I put up this easy ADC, which is my microphone, and run it into this, then I can hear it and go, hey, oops, I got to start it. Hey. So that's a lot of reverb, okay? All right, anyhow. So that's one way that you can get, when you go into the help patcher for RT-CMix and you look at the signal processing instruments, This is one way you can get the synthesis coming out into the signal processing. And that's perfectly legitimate. You can do that in Unity. You can do that in other things, as well. But I want to show you another way to do it, which basically relies on just using a single script, okay? And let me see. I think I was going to type this code out, but I think I'll just show it to you instead. Is that okay for you guys? Or do you really like to see me type this stuff out? Yeah. Okay. It's probably a good idea because I want to make sure we give enough time for Doug at the end of this, okay? So I won't save that because I already have it saved. And we're going to look at this one, Reverb Ambient 3, all right? If I open the script, there's this stuff up here, okay? Everything else is the same, except I've also put my G verb in here too. So when I hit this initialization, it's going to start up. Well, what's this doing? Well, this is a special RTCMix score file function where you give it the name of an instrument that you're using in quotes, and then you tell it where you want it to go. Now, nominally, wavetable defaults to going to out 0, 1, because that's the left and right output of your sound. But in this case, I'm kind of hijacking it and saying, no, go to this thing called aux 0, 1 out. That's just something that exists inside there's aux 0, 1, 2, 3, 4, 5, 6. You'll see some of that in a minute. Then I'm going to say, all right, for G verb, I want your input to come from aux 0, 1 in, and then send your output to out 0, 1. So you see, we've made a connection from the wavetable via that into the input of G verb, as if we'd just drawn the patch chords on the patch. And then that sends the thing out to the world. So that means that we can start up our G verb right here inside this same script, and everything should work as it should work. So let's give it a test, just to show you that I'm not telling you lies. Start this up, initialize it, play it. There we go. All right, that's nice, okay? Now, I want to show you one more thing, okay? This has nothing to do with reverb or auxes or anything like that, but sometimes people go, oh my goodness, I'm doing that thing where I'm adding two wavetables together to give it a slightly thicker sound. It's like multi-oscillators on a Moog. And notice that I've always said, take your pitch and then add a little bit more to it. Remember, this is that octave point pitch class, so this would take 8.00 and add a random amount between 0.00 and 0.0015. Now, people go, well, Brad, you're always making the notes a little sharp because you're always just adding to it, right? I go, oh, well, I'll fix that. I'll make it go between minus 0.0015 or plus 0.015, right? Makes a lot of sense, right? Wait till you hear what it does. Here we go. Start this up, play it. What's that weird high note? Keep listening, there'll be more. Notice that there's these weird high notes in there. Well, it makes a logical sense because if I choose a negative amount, it'll take that 8.00 and subtract from it. So it will come up with a number like 7.9995, okay? What does that mean in octave point pitch class? That means that you're taking the octave 7 and you're going 99 semitones above it. Which people go, oh, that's not how I expected it. Sometimes they go, well, that sounds pretty cool. But just be aware, there are ways around this. Doug may show you. Doug, are you going to show them some of the frequency conversion stuff?
Wasn't planning on it.
Well, you are now, okay? No. We have a lot of things that will convert from one octave point pitch class to direct frequency or something like that, so that you can work with it that way if you want. Yeah, we won't go into that in detail. We'll probably do that when we get to Unity because I'll need it for a couple of things. Okay, all All right, now, completely switching gears, we're going to do something different now. Okay, let me close this off. All right. Yes.
Just one quick question.
Okay.
For instance, the G verb, if we add it, so we tie the RTC mix to the G verb RTC mix.
Mm-hmm.
But what if we want to do a live control of the reverb? So we don't want it all the time, but we want to be able to control it.
That's a really good question because that's just what I'm going to show you now. Oh, wow. Okay. It's basically it's a way of controlling externally parameters of these instruments. All right. And we're going to kind of do something a little fun here. We use these things, well, yeah. Let me give you, first of all, something to differentiate it. We have had a way of getting information into the scripts by using those dollar variables. Remember when I said $1 and like it set whatever we were using $1 for, you know, things like that. When we're doing the strange attractor stuff, we would set the R value. Now, remember very first RTC Mix class, I talked about how this is a scheduled language and there's 2 points where you can do something. One is at the initialization time where it sets everything up, and then it'll say, play a note 5 seconds from now. Then there's the runtime of the note. What we want to do, the dollar variables are active during the initialization because they're setting values that you then use as you unfold your score. This other technique I'm going to show you now is active during the runtime, and it's what we call P-field control. Because this is historical, but all those numbers that we have for each instrument, they're called P-fields for positional parameter field. This goes back to like IBM nomenclature circa 1983 or so, all right? So there is a way, in fact, I'm going to show you the way right now, okay? And this one I am going to code up because it's really, really simple, okay? Glasses back on here. Okay, I'm going to take an RTC Mix instrument. I'm going to make it 2 channels. Now watch this magic. There's actually an optional second parameter here, like this. Look, it made another thing. Okay, and in fact, if I say RTC Mix 4, it'll make 4 of them there. So this is signal left in, signal right in, and then these guys are P-field control in, okay? So I'm going to just use 1 for this very basic thing that we're going to do, all right? And let me take this, and it's going to be so simple, I won't need an initialization or anything like that. And let me get my easy DAC going here. Boom, and boom, Oh, that's not an easy DAC. Look what I did wrong. An easy DAC. Good, that wasn't too embarrassing this time. Where's the little button? I don't see it flashing. Okay, so let me go in here, all right, and I'm going to say wavetable. No, I'm going to say VAT table, wavetable. Okay, start time is 0. Let's make it be 100 seconds long because we want to have some fun with it. Okay, amplitude will say 20,000. Okay, and then the frequency, I'm going to say freak right there. Okay, and then that's it. I'm not going to do any fancy waves or anything like that. Okay, well, what is this frequency? How am I going to fill this in? Well, I'm going to want to get the frequency from information that's going to come in that port that I set up by typing the 1 there. And I get that information by saying frequency equals make connection. And the connection type is an inlet. I want it to come from inlet number 1, the first one after all that stuff. And I'm going to give it a default value of 300 hertz. That's all I need to do, all right? So this will now get its frequency information from whatever I send it in there. Now, by the way, I'll show you that later, Jim, how you can control the other parameters and things like that, okay? You have to pardon me, I almost called you owner because owner was my Turkish TA for years. So he was also very involved in this stuff. Okay, so basically that's all set. Now, out here, I'm going to be sending information. This time I am going to use one of the cool Max object. I'm going to use a slider because that's just so graphic and everything like that. And on this slider, I'm going to give it a value, a range of, say, 1,000. And the output minimum is going to be 100. Okay, so let me get a thing up here, put this in here, and now this is going to go from 100 to 1099. Okay, so that's kind of like a nice range of frequencies. All I need to do is plug it into that. And now, when I hit this and I start it up, I see I have an error, syntax error.
I was gonna say, do you need a comma between the 1 and 3?
Yes, I do. Thank you, Andrea. I'm glad you told me after the fact. Now I'm embarrassed. Yeah, F for you. Okay, here we go. I'm not going to bother to save this because I already have it done. Okay, so now I start it up. You're playing a theremin. Okay. Okay. So that's what there is. Now, again, the runtime thing. Let's say we want this to start at 7 seconds from now. Okay. Start it up. Play it. It's not doing anything. It's not doing anything. It's not. It's not. But here it comes up to 7 right about now. There it is. So these P fields only become active when the note starts to execute. Okay. But that's what we want because we want control over them when they do their thing. Okay. All right. Now, here's what I was going to show you that will make you happy about controlling signal processing stuff. Okay. If you go to like gverb, notice that some of these are in capital letters. All of the variables that all the parameters that we have listed in capital letters are P field enabled. So you can actually create an external control like that and have it come in and you say amp equals make connection, whatever inlet it is, and then put the variable amp there. Then you can control it directly. So you can control the room size in real time, the reverb time, damping, all this stuff, with sliders or some kind of external control mechanism. Okay. And again, that's going to be important in Unity because we'll use things like position of objects to control them, things like that. So yeah, it's a handy feature, very handy feature. All right. Yeah, Doug, I'm just about done. All right. I'm going to do, the last thing I want to show you is sort of sound files. And yeah, let me get rid of this. How we do sound files in Unity. I mean, Max MSP, don't save. And I'll just show you directly. I have a sound file here that you all heard. It's frogs. Yeah, that was recorded outside my house where I used to live in New Jersey. So we lived.
Frogs are loud.
They were insanely loud. I mean, I'm not kidding. Yeah, but you guys have everything in Australia like kills you though. Yeah, if you did, they would kill us. I mean, let's be real about this. Right. Okay. Here's how you get this to happen. Okay. This is the basic RTC mix thing that'll do it. Now this one is fading in. How did I do that? Well, let's look at the script. Okay. I made an amp env, and then I use this instrument called stereo. Now stereo takes an output start and input skip, and this time I could actually skip in on the input file. If I wanted a particular frog that was like 10.2 seconds in, I could say 10.2 on that. This is the duration, and then 1 times the amp envelope. Remember, this is processing the signal that's already there, so we're just multiplying it by 1, okay? We could multiply it by 0.5 if we wanted like mellower frogs or something like that, okay? And then this business here, 0 and 1, okay? This is this is like output 0, which is the left channel, and this is output 1, which is the right channel. I'm going to take input 0 and put it into output 0. I'm going to take input 1 and put it into output 1, okay? I could actually reverse them if I wanted, or I could make them both be 0.5 and make it like mono, but this is just the way that you can like kind of use the different things. There's another instrument called mix that works very similar to this that I'm not going to show. But basically these are just straight ahead, take the sound file, do stuff with it. Now, notice this RT input thing here. all right? This is where it gets tricky. RTCMix has no notion of where a max patch is located in your file system. So what I have to do is tell it exactly where the frogs sound file system was. Now, how did I get that? If you go out here, there's a similar way to do it on Windows, but I don't quite know what it is. If you select it and up here do a get info on it, you'll see that it says right here, where, okay? And I can select all that nonsense and copy it, and then go over here, and I can paste it in there. And that's what I would put in once I would have to put frogs.wave obviously on the very tail end of it. But if I put that inside quotes in an RT input, it'll find the sound file that way. Okay. Now, there is another way to do it that's only Max MSP specific, okay? Now, by the way, when we deal with RTCMix in Unity, there's ways that Unity, you construct the path to the sound file at runtime. And they have, I mean, this is a common problem, not just for sound files, but for any file that you want to load in an application. You know, you have to be able to find the file on the file system, no matter where the user puts their application. So it's done dynamically, like kind of doing what I just did, all right? Is this clear to everybody? Okay, hope so. There's another way to do it, but it involves getting the terminal down and doing all kind of nonsense like that. But there is yet another way, okay? And I'll just show you this because we're going to turn to Doug momentarily here. And that's this thing, okay? I used the buffer tilde object in MaxMSP. And buffer tilde, you give it the name and you give it the name of the file. And if the file is in the same directory as your max patch, it will find it. And if I click on it, you'll see, look, there's all the frog sounds, okay? See, they're going like that. Pretty good at it, aren't I? Okay. In that case, when I turn this on, I have to send in this thing that says buff set frogs. You have to do that every time you turn it on. And in here, the RT input, I basically say it's an MM buff or a max MSP buffer. And then that's the name that I gave the buffer. And then this will work. Yeah. Now, notice that nice fade up, okay? This is a technique that I do want to show you. I made this to fade up for 25% of it and then fade down for 25% of it. Now this isn't going to, now it will play for 30 seconds, but notice that I'm generating a max bang at 21 seconds. What this means is that as that one play of the frogs begins to fade out, the other one's going to start to fade up, okay? And this is a way of basically being able to create a continuous patch of sound that doesn't sound like it's repeating, because 20 seconds is too long really for your memory to remember, unless you've got a dog that goes woof right at one point in it or something like that. But if we'll just kind of give this a listen. Oh, I forgot to do the buff set. Okay. And you'll see it happen over here because I don't have it print off, but you'll see when the fade starts. By the way, those frogs, they're only about this big. There it goes. See? And you can just let it run forever, and it'll always sound like the frogs are just like frogging around, you know? So this is a really good thing if you want to have like ambient sounds going in the background of Unity scene or something like that, or say you're just doing an interactive app and you just want to have this going forever or something like that. This is a nice way to do it. Okay. All right. And I believe that's all I have to say right now. So I'm going to turn it over to Doug, and he's going to show you some more esoteric and fun parts of RTCMix. So Doug, I'm going to stop my share, and it's up to you. Yeah. Oh, Doug Scott, right. I introduced him last time, right? Yeah. Okay. Y'all know he's Okay.
All right. Well, I actually wrote up a. So how is the text size on that right there? That who am I?
It's fine.
Is that this?
Yeah, it's even
Okay.
good for
So
me, so that means everybody else can read it with no problem.
okay. So I just thought I would provide a little more context about me so that the difference between the way I work and the way Brad works might have a little bit more context. So you do know that I'm a former student there at Columbia. I was a DMA comp student and Brad's teaching assistant. I worked with him to set up the studio when we first got new equipment. At that time, it was a Sun computer workstation, and we had a lot of work to do to get software up and running. I actually learned how to code in C. I raced to figure out how to do that just in time to be a couple weeks ahead of what the grad students who used the equipment were doing. So um, um, as a result of all this, I became very, very interested in programming, and that sort of set my fate going forward. So I was at Columbia for about 5 years, and I ended up dropping out of my DMA to take a job setting up a computer music studio in Texas. I completed all my coursework. um, um, and then I began developing new software tools to expand what could be done. This is, as Brad has talked about, this is in the late 80s and early 90s. And really about 90% of what is out there now did not exist in any form whatsoever. So there was a lot of free space to develop new things because no one had done it yet, or at least no one had done it and distributed it widely. And then the other thing I began to do was to expand and improve on RTC Mix, which is something that, as Brad has said, I have continued to do to this day. Recently, I retired from my programming job. My last one was at Apple, and now I basically write music full time, and most of it uses RTC Mix. So I wrote this up just as a detailed description of sort of how I think about RTC Mix. So I won't read everything in here. Couple things that are sort of important to me are I do a lot of stuff with natural sounds. So I use a lot of RT input. I like to layer stuff. I'm very, very into sound placement. So I use a lot of the reverb and placement software that RTC Mix has, and wrote quite a few of the instruments that you can use to do kind of simulated placement of sounds in rooms with different kinds of reverberation and things like that. I'm very interested in something that I call constrained randomness, which Brad's actually demonstrated when he varies the pitch of the sound by a very small range. That kind of technique is what I'm interested in to, as I said here, to get away from what I call the horror of absolutely regular beats, volumes, lengths, and things like that. So all throughout my scores, you'll see millions and millions of uses of like plus IRAM, some small range. And a lot of this is to give the music a kind of more human sounding realization, and gets rid of any of the kind of real direct repetition of things. I'm also, let's see. So I'm also, I tend to restrict my tools to a very small number of, that is like what things in RTC Mix I'm using. I tend to restrict myself to a really narrow set of tools and use that as sort of one of my constraints in how I put a piece together. All right. All right, so Brad asked me, Dr. Garton, as I wrote in my notes, asked me to talk about a particular problem with using that bus config, which you use to send the output of one instrument into another before it goes to the output. And I have some samples to show that. All right. So let's see if I can get this. I made the font really big. Let me make the font a little smaller here. A little smaller still. Gonna fit. That's good enough. Okay. So what I've done here is loaded in a long sound file, which is mostly speech. And to demonstrate sending us the output of one instrument to another, I've done a bus config where I'm using this trans instrument, which is really simple. It reads from the input file and transposes the sound up and down and then writes the sound out. So I'm doing the same thing as Brad showed, where I am reading in from the file and I'm sending it to one of these auxiliary buses. Then I have another instrument called Moog VCF, which is it's a fancy filter that sounds like one of the famous analog synths of ancient history. Where, as you can see, the aux out here is matched with an aux in, and then I write it to the output. And then what I did is I created this, by the way, I'm going to make these scores available to Brad because I tried to document them as well as I could, so they might be useful going forward. So I put a note in here, creating variables for all your instruments or arguments makes it easy to remember them. So instead of doing hard-coded like for, I'm very big on actually creating all the variables and then passing them to the instrument. So we have a trans call, which starts 67 seconds into the sound. It writes out at time 0 for the duration of 5. It transposes the sound down a half an octave, and then it writes it into this Moog VCF, which has a couple of parameters. One of them is cutoff frequency and one is resonance. The point of this first score is that if you look at the time that the first one is written out, you'll see it starts at 0, and the time of the second note starts at 5. And this is important for what the problem is going to be. Let me just play this here.
A shot carrying more or less.
So what I had is 2 events where I read from different places in the input file. I transposed them to a different amount and I filtered them by a different amount. Okay. And all of that worked just fine. There was no problems at all. We heard one sound, there was a little tiny gap, and then we heard the second sound. Now let me go to this file, which is virtually identical to the first, except that the first one, the sound starts at 0 and goes through second 5. In this one, the second sound here starts 2 seconds in and then goes for the same duration of 5. But there's going to be some, listen to what happens when I play this. What happened? Well, distortion, but not only that, if you listen, so remember that in the original one, you hear the first sound in the, I assume it's in your right speaker, and then you hear the second one in the left. But listen to what's happening here after 2 seconds. So what happens? The sound ends up crossing over to where the second sound's supposed to be. So I am going to try something that I have. Let's see, if I go to Zoom, I want to create, I was going to create a white, where is it? Whiteboard. Woohoo. New. I don't want a template. I want a new whiteboard. Okay, this is more complicated than I thought. Let's see.
We can't see what you're doing at all. It's really amazing.
Yeah, that's because you can't see the Zoom the Zoom app window. What
Right.
I'm trying to do is
Your
just,
cursor is like jumping all over the screen and doing weird things.
yeah, I think that Zoom makes its own, um,
Right, you'd have to share the thing. It should show it should share that though. Huh.
okay, well, this isn't worth the effort here. So let me actually just do it here. I'm just going to create a little picture here. So when you read from the input file, let's say that's your input file. So when you start reading at time 0, you're basically starting reading here. And if we write that into an aux bus looks like a stream of audio, just like the input file does, and you can write to it at different points. So what happens is that the first event wrote into it starting here, and the second event wrote to it starting here. But because both events read from the same aux bus, what happens is that the instrument that wrote into that bus wrote the information so that if you try to overlap the two, it actually the two interfere with each other because you've tried to read from a chunk of the file where there is both data is located. In other words, if you write all your data into aux bus 0, then when you try to read out of it, you're going to have any place where you're trying to read data that overlaps, you're going to get that collision like you heard. Now, there's 2 fixes for that, and I'll show you the kind of real simple one first, and then I'll explain why it isn't the best sort of in the ultimate sense. So this again is the same score. The only difference here is if you look at the bus config here, that's for this first event. And then we have the second event. You'll notice I called bus config a second time. Now I pass it. So now trans is writing to aux1 out, and Moog VCF is reading from aux1 in. And if I play that, notice that you get both sounds overlapped, but one is on the left side and one is on the right side with no problem. Now, why isn't this the ultimate solution? Well, let me give you an example from my music, not playing it, but I'll tell you what happens. I like to take the output of an instrument and write it into another instrument and then write that into another instrument and then write that to the output. And I do that in sections of sound that are like 1/10 of a second long, and I put 50 of them on top of each other. So if you had to make that work with this rule, which is any overlap needs to be on a new bus, think with that how much difficulty you have, and you run out of buses. If you try to put 50 sounds overlapped, all slightly different, you will run out of buses. So I invented a new solution.
Yeah, I think our upper limit is 32, right, Doug?
I think I coded it for that. Yeah, I at one point I hacked mine to be 128.
Yeah.
Okay, now I'm going to go through this, not to expect you to get all the details of it. This is a really powerful way if you like to create like meta instruments, like something transposes and it echoes and it filters and it reverbs, and you don't want to have to deal with running it through aux bus 1 into aux bus 2 and so forth. We have an instrument now called chain. And chain has some tricky stuff in it, but what I'm going to show you here is that what you do is you tell the instrument that it's going to write itself into chain, and then you give it a number out, just like you had aux blah blah out before. And then the next instrument that you expect to be putting into the chain, you follow the same rules. This one reads from chain in and writes to chain 1 and 2 out. Why 1 and 2? Well, because this instrument reads mono data and then writes out stereo with a pan. And then finally, you tell chain that it is going to write out its output into the output stream, the same as we did with the other instruments and those other scores. Okay, so what does this look like down here? Well, most of this is exactly what you saw in the other score, except you'll notice that there are no calls directly to trans or Moog VCF. Instead, there's this weird thing called make instrument. And what this does is, this is all the same as when you called trans, except for that the name trans is actually passed as a string rather than being put on the command line like this, right? So this creates a thing I call an instrument handle. I create another one for the Moog VCF. And all you need to know is the conversion is you take whatever the argument was, you turn it into a string, and then you call make instrument. Now the tricky part is chain takes outskip just like mix does. It takes a duration just like mix does. It takes an argument for how many instruments you're going to be handing it, which in this case is 2. And then you give it the two instrument handles. Now, what happens when you run this? Well, chain has a storage in it where it stores these handles that you have that you've handed to this. You can hand this any number of instruments. And what it'll do when it runs is it will run each of those instruments in order, and internally it'll shuttle the data from each one into the next one, into the next one, into the next one, so that you can create a kind of a meta instrument. And notice there's no auxiliary buses in here. So basically, every time you call this, it's completely independent of any other call that involves these instruments. So you could have 500 of these sounding at once, and you'd never have to worry about any bus interfering with any other bus. So if we listen to this, so no problem with overlapping. There's no dealing with any intermediate buses. And this system is extremely flexible. Like I said, you can stick a whole bunch of instruments one after another and not have to worry about any kind of intermediate buses or things like that. So the RTC Mix manual has a description of both make instrument and chain, and gives a couple of simple examples, I believe. So
yeah, this is stuff. Doug is going to be showing you some pretty advanced stuff. Just kind of file it away, and at some point you might need to use it. Yeah, this is actually a very powerful tool, because you will run into this problem at some point probably, where you want to have overlapping events, and all of a sudden it's starting to distort. This is the solution for it, and that's when you can write me or Yankee. We can help you figure it out.
Right. Like I said, I'll make all of these scores available so that you can see the examples. Okay. All right. So that was something that I had as a special topic that Brad wanted me to run through. My other goals in talking to you there's just basically 2. One was I wanted to introduce a couple of techniques which make it easier to write your music using scores. And when I think of easier, what I usually think of is keep you from having to do a lot of things over and over and over again. Or do something with one line that before took you 5 lines to do, or something along those lines. And the second thing I want to do is show you a lot of score and music examples without going into any great detail, because as Brad pointed out, I just want to give you a sense of what you can do with this system as you become more and more familiar with it, because it is truly unlimited. All right, so let's just go to a couple of things here. Okay, I created a very, very basic score. That's it. figured that would be my starting point for a bunch of stuff. Okay, the first thing I want to talk about, and Brad, you haven't talked about include
Not at all.
right?
No.
Okay. So we have a command in RTC Mix called include. And it's very straightforward. What it does is it says, at this point in the score I'm currently in, I want you to pull in the contents of some other score, as if it were just pasted into this file. So let's say what I'm going to do here is, let's see, I am going to say save as, and it's going to put it into the directory I'm currently in, envelope.include. The name does not matter. It's just whatever's easy for you. Oh, I see. It puts a .score on the end. Okay, that's not a problem. All right, now let's go back to wavetable. And what I'm going to do is just say include envelope.include.score. I'm going to double check. I might need to put a path on that. Let's just see what it does. It works.
Hey.
Okay, how does that work? Well, I took the envelope call that was at the top of the file. I saved it out into a file with this name. And then when this includes it, it's just like that file had been pasted into this window. Now, why is that useful? Well, as you start working, you're going to find that there's a lot of stuff at the top of your scores that you have to keep typing over and over and over and over and over and over again, because you'll work in a particular way and you'll have certain things that you like to do, and you'll get really tired of doing that. Well, if you take anything that you type over and over and over again, and it's always the same, and you put it into a file like this, you can just stick this include at the top of your file, and it will pull that in. Now, this includes things like user-created functions that Brad talked about a couple weeks ago. The idea
Last week, actually. Yeah, no,
Yeah.
2 weeks ago when we did fractals. Yeah,
right.
yeah.
So you can create a bunch of user functions that do things that you like, maybe add two pitches together without giving squeaking noises, right? You can actually write one of those and stick it into a include file, and now you've created the beginnings of your own custom library. And this is what I do to the max. I have hundreds of special custom user functions that I use to do a lot of work for things that I do over and over and over and over again. All right, that's one, include. The second one is for people who are interested in random and chance-based stuff with probabilities. Don't save. Let's go back to here. So let's take this and see. I'm going to show you something else right here. There's a, if you don't like typing n equals n plus 1, there's a shorthand, which is just plus plus, which says make this 1 bigger.
Doug, I didn't know we had prefix and postfix operators.
We only have a prefix.
Oh, we don't have postfix. Ah,
No.
okay. I didn't know that though. Wow.
Yes.
Cool.
All right.
Us.
All right. So right now, okay, so let me change this. Out skip. So I'm going to start off with my out skip equals 0. And then I'm going to say, and here's another one, out skip plus equals 0.25 duration. We're going to make these short 0.1. Okay, so again, what does this do? This just says every time we go through here, outskip is bigger by 0.25. So again, a little bit of shorthand. So you don't have to say outskip equals outskip plus. That will continue to work. If you're comfortable with that, that's fine. Again, I'm looking at shorthands, shortcuts, ways to make less typing, because that's really the way I roll. All right, let's see. Does this play? It does, and it's very exciting. Let's make it a little faster. All right. So what I want to show you is a shorthand called chance. Chance is all it is if any of you have ever played a game where you've got a die, this is a die. The first one is, this is basically chance of 1 in 2. So this should be a 50%. Let's say we wanted it to be 1 in 5. Let's say we wanted it to be 7 out of 8. Okay, so this makes it really easy to set up parameters for how often something happens, because that first and second value are something that you can tweak those using some other part of the system. For example, I could do this. Sorry. All right, so it's going to start off, basically one out of 2, and then we're going to say, let's do it this way. So what's going to happen as this goes? Denominator is going to get bigger and bigger, which means we're going to have 2 over 4, then 2 over 5, and 2 over 6, and 2 over 7, and 2 over 8. So it's going to get less and less likely you're going to hear a tone. Very unlikely. let's change the out skip here. We're going to half this so that
I think you're going to have to add less to your denominator too. It's going too quickly.
we'll only have it happen when you play a note.
Ah.
And so forth.
Yeah.
Anyway, so that's just a shorthand for probabilities, useful if you're trying to do stuff like that. All right, one more. This is something that's directly out of the RTCMix documentation, which is something called SAMP table. SAMP table is a way of reading out of a table of values that you have. Okay, sorry, this is my envelope. You can create a table of values and then read out of that table and use those values that you've read out as P fields that you're handing to instruments and things like that. So with the way this is currently written using IRAND, it is what it's doing is it's randomly picking from these pitches in the table. You could also instead change this so that it walked the table through and then wrapped around and came back to the beginning. So you could use this to create a kind of sequencer in a sense, where you had some arbitrary number of values up here, and then the system simply walked through those values over and over again. it's just a cool way to get access to a table. And there's a million ways to create these tables if you look in the documentation. And all of them are then going to be filled with numbers. And then you have a way here of using those numbers to control something in, in some kind of a loop or other situation like that.
Yeah, so that's where this is different than the array method that I've shown you before. Make table, like Doug said, has a lot of different construction techniques. Where with an array, you just like put the numbers in. Yeah.
Right. In other words, with an array, you are completely responsible for figuring out how to fill it. I actually have an entire file full of array filling user-defined functions that I include when I want to do stuff with arrays. So again, all that stuff is possible. This is just a shorthand for that. Okay. All right. So now I want to go off into crazy land.
Where you see these scores.
Okay.
Doug knows what he's doing.
All right. Just to show you.
Gosh, Mr. Scott, what does that sound like?
How long is this? 1 second.
Yeah. See, he was a Columbia back when we really wrote music. It was hardcore.
Now, what you need to realize is that the length of the score, this whole thing could produce 0.1 seconds of music. There is no relationship between the length of a score and how much it does. You can write a 3-line score that lasts forever. So what the complexity here is what it does. So this score creates an entire piece. And by creates, I mean, I did not write this piece of music. Now I want to prove that by setting the rand seed from 1 to 2. Okay, now I want you to keep that in your head. Now I'm going to set it to 3. You hear how the bass line is different every time?
Mhm.
That's because this piece is entirely algorithmic. It has constraints and rules and ways in which the different parts are generated, but what gets put out is based upon a random seed. So every time I change the seed, I get a new piece. They're obviously related to each other. But so it's a little difficult to explain how I did it other than to sort of talk about how I created some sort of meta instruments. Like this is a user-defined function, which is really a meta instrument because you can see here, I have 3 calls to make instrument, passed to chain. So start is a car plus strong, mode VCF you've seen, and place is a reverberator. And so this becomes a filtered strum reverberated instrument, which I then use just like it was an instrument on its own, because see, it has outskip, dur, pitch, and so forth and so on. There's a bunch of stuff I do to get the piece to fit together. There's each part has its own rhythmic description and so forth and so on. Obviously, I just want to show you the kind of things that this can do. Let me see what I've got else. Oh yeah, I wanted to play this because of the discussion about recursive scores. So I have this function scatter, which you'll notice calls itself in a special loop. And what it's doing is it's reading from a set of files that I have. I just simply created an array with file names, and then the score goes in and picks randomly from those files, and it does some random panning and some transposing, but each layer of the recursion does something different because I actually pay attention. For example, the transposition is dependent upon how deep you are in the recursion, because see how when it gets called in here, notice that the last argument is depth plus 1. So each time it's called, this number gets one higher, and I use that depth to control all kinds of things in here: pan, duration, sampling, pitch, and so forth. So here's what it sounds like. So that's 10 layers deep, where each layer is more notes. The other thing is that each layer inserts a copy of itself into it divides the total time into 2 parts, and then it inserts itself into each part, and then each of those parts divides itself into 2 parts. So it's basically it's a fractal, it's a recursive fractal note generator. So and it's got a golden mean division in it as well. So
Those were all made from the piano sounds, even those like weird belly things. That's just because they've been transposed outside their like normal range.
Right.
Okay.
Right.
Got it. Cool.
So that's just an example of what you can do with recursive stuff. All right. Do I have anything else in here that I wanted to play? Oh yeah, so I wanted to show you something that I just finished a week ago. Show you a score. So this one's not too terrible, but it also, you'll notice I have a bunch of includes at the top. So I'm pulling in a bunch of stuff which is used over and over again in this piece. So for example, this is a bunch of stuff using tables. This is a thing that allows me to add and subtract pitches. This is some stuff that I use to wrap around make table to make it easier. And this is because I'm using a layer to create a room simulator as well. And all of this stuff is stuff that I do in a lot of my pieces. So that's why I stuff it off into these include files, because I don't really need to fiddle with that stuff for the most part. All right. So this instrument, this score uses an instrument called a phase vocoder, which does a cool thing of slicing up the input sound, turning it into a into a fast Fourier transform, which is a way of displaying frequencies and amplitudes. And then it takes that information and resynthesizes it back out to the output. And you can stretch and shrink and transpose those sounds in really, really incredible ways. What I'm doing here is reading in from a set of guitar samples. You can see that, where is it?
Is it in one of your include files?
I'm checking to see, it is because I use, I have to remember what it's called here. Oh, load note. So what I do is I basically determine which guitar note I want to load based upon the pitch in octapoint pitch class and a dynamic, which is one of, oh, it's not visible here, but it's basically one of four levels. So again, I didn't want to have to figure out, oh, which sound do I need to load if I want to play a middle C, fortissimo. So all that stuff is hidden behind the scenes, and it makes this score, if all of these include files were pasted in here, the score would be probably 1,000 lines long. But what does it do? Well, it does this. It goes on for a long time.
If you guys want, there's a link on the syllabus it says Doug Scott. It will take you to his SoundCloud page where you can hear a lot of these compositions that he's made.
Oh yeah, I was going to say that if you go to my SoundCloud page and you look at what's called my disquiet junto list, and you can look at, on my page for a description of what that is. There's like 50 pieces in that playlist, and if in their list of hashtags there's a hashtag RTC mix, then that piece was created with RTC mix. And I think all but about 3 of them were. So there's like 48 pieces there, all created using RTC mix.
Mm-hmm.
So the only other thing I'll say about this is that in the way I work, the highest level stuff is at the bottom. So what this code here does is it says, for the arguments in this array, which are, each one of these is if you look sort of carefully, they sort of look like the arguments you might give to a function, and they sort of are. I basically walk this list, and for each one in it, I get a set of arguments, which I then pass to this thing, and this is a user-defined function right up here, PV move chord. So what does PV move chord do? Well, it plays from a list of pitches like this. It does a loop and starts a call to pvoke move for each one of those pitches. And what this is I have low frequency oscillators controlling the gain of each of the notes in this set of pitches. That's why when you hear it, all the pitches sort of cycle in and out, sort of independent of one another, because each of those tones has its volume shifting, up and down according to a somewhere between 0.01 cycles per second and 0.08 cycles per second. Okay, so then this one calls another function, which is this one, and this is the one that actually makes calls directly down into the phase vocoder. And then this is a very high level thing that I have, which basically sends the output of this through into a room simulator and moves the sounds around, and a lot more stuff going on. But I just wanted to, you can see that this is huge. It's very complicated. I build these up in layers as I say, what do I need to do over and over and over again? Well, notice that this thing needed to be done over and over again. And to make it happen, it needed to do something more basic over and over again. And so this one then is the one that I call over and over again, but the code doesn't have to exist more than once in the system. And let's say I really, really liked what this did. I could just take this and copy it into another file, and I don't have to redo all that work. I can just call it just like I do here.
Cool.
All right. I think that's probably, I mean, I have lots of other scores. Let me just play a couple of other. Let's see. This is a piece I wrote a month or so ago. Again, you can see the score is got a lot of stuff going on in it. The sound of it is actually much simpler than what it looks like. So if I let it go on, it does change. You'll see this one is a little less random than a lot of the ones I've done. I've actually written out a source set of chords here, and the code walks through those, and there's some special work to produce the repeated notes. And I don't know if the speakers that you're listening to let you hear the fact that each of those chords sort of slowly rotates around the room as it plays. I mean, I'm not sure if that's comes through, but like I said, I'm very into moving sounds around in space. So I pretty much all of my pieces make use of my my library of functions, which lets me easily move sound around in space. Okay, that's a lot. Just wanted to give you a sample of a little bit of stuff. Like I said, there's a lot of pieces you can go and listen to if you want to hear, and a bunch of this stuff I'll make available. If Brad ever creates a Discord channel, I'll lurk on it. And
yeah, I think we have one, but like I don't even. Yeah. Anyhow.
Oh, you did create one?
Well, Yangchi has been. We will have one. Yeah, we will have one. There's some
cool.
CMC Discord channels, and we're going to put one together here. And we can Discord.
Cool. Okay. So, I mean, I guess I should ask if there are, with that mass of stuff dumped on you, are there any questions that I can answer to just maybe clarify any particular point or?
Yeah. If not, I'm going to show just a few more minor things. Okay, nothing coding or anything like that, you know. But first of all, yeah. And Doug, I should mention, Doug is very, very committed to RTC Mix. If there's something that you'd like to see it do that it doesn't, if you write him, usually the next day, he will have like the code ready to go. So yeah, he's a tremendous resource. All right. Yes, yay, thanks, Doug. I just want to show you a couple of quick things. Let me share this real quick. And right, I think you guys are all seeing that, right? This is what I wanted to show. I've shown you this before, but I'm going to give you a bit. Okay, I'm not even going to do anything. I'm going to just simply option click on this, or option click after I unlock it, and bring up the help patch here. And give you a bit more information about what's here. This is a very simple thing. I wanted to show you this, okay? Because people have been saying, you know, what instruments are cool to use? What instruments are kind of fun to use? Well, this basically uses a physical model, and I'm going to show you those in a second, because this is one of the things that RTC Mix has that a lot of languages don't. These are very powerful and sophisticated instruments that are pretty easy to use, and basically you can just kind of like hit this. Yeah, that was actually all from one physical model. It's called a modal bar, and it's a basically physical model of how like a bar works, you know, up and down. And yeah, you'll find some other kind of goodies in here. This is one of my favorites here. This is written by John Gibson, and it shows you this instrument called Wiggle, and it sounds like this, okay? You can get a lot of really interesting sort of sounds out of it. A couple of others that are kind of fun are, yeah, we won't look at LPC really. Jake Grand Place is kind of fun. That's another John Gibson special, where we do this. And the big repository of stuff is in these score file samplers, 1 and 2. 1 is the basic instruments, 2 has instruments that are often like ganged together to make a whole chain of different instruments and things like that. And the way you can use it is that you can go to here and go to the reference, go to the instruments. You can go down here and go, I wonder what the heck wave shape sounds like. You can read about it here, but then you can go back over to your Max MSP patch, and where's my the help? And go down here to the score file sampler, and chances are you can find, what was I was looking at? Wave shape, right? There it is. Well, I can bring up a score, give it a listen. So yeah, maybe useful. Oh, here's more. Wow. Okay, so that's a good way to kind of explore some of this stuff. Now, I should point out to you that a lot of these things that do signal processing, like for example, am1.score, they work best a lot of times on files, but we had to kind of set it up so that it was always using real-time input just because we had all the scores in one place. So I can basically hit this and go, hello, can you hear me? There's some AM stuff going on with my voice right now. And I think in the next one, it'll be even weirder because it'll get faster. And now I'm really AM. I am your father, Luke. You know? Okay. So this is a way of kind of exploring what different instruments are out there and kind of seeing what's possible. Okay. That's, I think, all we have. Doug, thank you so much for that wonderful presentation. You know, it was really, really pretty cool. And that's one of the better ones, I think, probably the best one I've seen you go. I really enjoyed it. And I learned new stuff too, even. Oops, I wanted to quit that. Don't save. Right. And so now I'm going to say goodbye and stop my share. And then I'm going to
Okay.
stop the recording. All right.
See you later.